Hey there, my SQLers. So this video we are going to just throw in a little bit of a hodgepodge of MySQL commands, and I'm going to use the bakery database again, but I've made some changes to it, so I just want to review some of those changes. The customers are going to remain the same, so we have Elrod's Pizza in Pittsburgh, Scooby Snacks on TV Land, and Joe's Eats in Greece, and here are their ID numbers. Then we have some ingredients that we can put into our cookies. Obviously not an extensive list and definitely not accurate, but we have flour, sugar, butter, chocolate chips, and vanilla extract. And for each of those, we also have a calorie count and the units by which we're measuring these. And here's where I've made a change from the previous video, and I've added vanilla extract and put this in at 2 calories per teaspoon. Clearly not right. And I changed the units on chocolate chips. Actually, here I kept those the same as bag. And then, let's see, over in cookies, I made some changes here. I made the units in cookies consistent with the units in ingredients, so I didn't have to do a unit conversion. We could do that by setting up another table that has the conversions from one unit to another, but for what I wanted to demonstrate, it just seemed like a lot of work to do all of that. So this is for a sugar cookie, the amount of the ingredient that we want to make the cookies, and this is how we measure it. So we want 1 cup of ingredient 1, so 1 cup of flour, and 1 cup of ingredient 2, so a cup of sugar, and then a tablespoon of butter, and so on. And then a change here is that for sugar cookie, I've added an ingredient 6. So the two changes are in ingredients, I've added an ingredient 5, which I didn't use over here in cookies. Now, if I was baking cookies, I would, but for this table, I didn't use those. And for sugar cookies, I've added an ingredient which actually is not in the list of ingredients over here. Now, the other thing that I've done is I've removed, when I created this table, the foreign key restriction on foreign key ingredients, cookies ingredient, that be the same as ingredient ID over here. And I had to do that because otherwise, if I put this 6 in here, then MySQL will complain that there's no 6 key over here. Now, why did I do this? Well, it's because I want to demonstrate another MySQL command that makes use of the tables this way. And then the orders, that's actually stayed the same, so there's no changes there. So let's see, this is, who is this? Elrod's Pizza has ordered some sugar cookies and some chocolate chip cookies, and then another batch of sugar cookies, and then Scooby Snacks, is it? Yeah, Scooby Snacks has ordered some chocolate chip, and then Joe's, whatever that is, Joe's Eats orders a bunch of cookies. Okay? All right, so now I want to go over and look at some of the new commands that we're dealing with. So I'm going to use this bakery database, and I'm going to just join together the cookies and ingredients. So this should, if I look at cookies, right now what I get is a sugar cookie has an ingredient 1, which is not terribly useful. I get an amount in a cup, and then an ingredient 2, ingredient 3, and ingredient 6. What are these ingredients and what's some information about them? So I'm going to join those together, and I'm going to get the cookie, the ingredient name, the amount, the measurement, the calories, and the units. So I'm going to pull all this information together. And when I do that, here I get a sugar cookie contains 1 cup of flour, and that's 100 calories per cup. A cup of sugar, 150 calories a cup. Notice I've made the units here again. I've made those the same. So 1 tablespoon of butter, and that's 100 calories per tablespoon. Again, these numbers are made up. And then we see for the chocolate chip cookie, we have a cup flour, consistent 100 units per cup, and etc. Okay, so that's a join like we've been doing before. And notice that there's something missing here. So what's missing? Well, if we go back over to the cookies, sugar cookie had an ingredient 6. So sugar cookie had 4 ingredients, right? 1, 2, 3, and 6. But if we go over to this join, we don't get all 4 ingredients. We only get 3. So why do we only get 3 ingredients? Well, because this, when it does this join, it recognizes that this ingredient 6 doesn't exist in the ingredient list and says, well, I'm just going to leave that one out. You can, however, force that ingredient to appear. And so cookie, there's a cookie that has an ingredient that doesn't appear in a list. If we do a left join with cookies and ingredients, then we get that, well, okay, so it's in a different kind of order now. But we have sugar cookie with flour, sugar cookie with sugar, sugar cookie with butter, and then there's this last sugar cookie that's null. So when you do the left join, that's going to take all of the information from the table that's in the from, so in this case from cookies, and it's going to try to pair it with everything from ingredients, but if there's no pairing, it's just going to put nulls in those values. And in a reciprocal way, we can do a right join, and this is going to pull in all the ingredients, and if there doesn't happen to be a cookie that has those ingredients, then we'll get null in the cookie spot. So remember, there's an ingredient vanilla that doesn't correspond with any cookies, and here it is, vanilla extract, and there's no cookies for it, but we do get the information from the vanilla extract. So there's different ways that you can do a join. You can do a regular join, you can do a left join and a right join, and the left join just makes sure that you get all the information from the table that's in the from statement, and the right join makes sure that you get all the information from the table that's in the join. Okay. Now we're going to go and do something completely different from joins. Well, I suppose this does have a join in it, so I should say, continuing on with the joining theme, I want to create a rather large join, I guess. So I'm going to put together orders, customers, cookies, and ingredients. And what I'm going to do with this is, well, actually, let's just run it. And so I'm going to see that Elrod's Pizza has bought 100 sugar cookies. The sugar cookies contain some flour, and they get 1 cup of flour per batch of cookies. And so I guess this is 100 batches. There's 100 calories per cup, and then we'll get into this total calories business. So anyways, this join we're doing, we are pulling out the business name and the cookie name, which was listed as a foreign key under, oh, let's see, where did it go? Cookie name. Yeah, we're going to edit all this out. Cookie name. Well, it doesn't matter. Oh, under orders. So this is a foreign key under orders, right there. And now, we covered this in a previous video. So I'm going to rename cookie name as cookie name. And then we're going to have the quantity of cookies ordered, the ingredient name that goes along with the ID for the cookie, the amount of cookies, the amount of the ingredient that goes into the recipe for that thing, the measurement used for that, the calories for this ingredient, and the units measured for the calories. And then I'm doing a different as statement here. So here, cookie name is just a relabeling of this foreign key, but now I'm computing a new column that's the quantity times the amount times the calories. So we go down here, I have 100 batches of cookies, and each batch of cookies contains a cup of flour, and there's 100 calories per cup. So the total calories for this batch, or 100 batches of cookies, is 10,000 calories. So I'm computing this quantity, and I'm giving it an alias. So I'm calling it as total calories. So we get this total calories. Oh, never tried that before. Apparently, if you click on that, you can change how you're sorting things. Anyways, get distracted. Okay, so to do this, we're joining again together the orders database and the customers database, and we're making sure that the foreign key in orders is the same as the ID of the customer, and that the foreign key for cookie name is the same as cookie name, and the foreign key for the ingredient is the same as the ingredient in the cookies table. Okay, so we're creating this large table. Now, there's something new here. So I do this as one select statement, but I decided that there was other things I wanted to do with this table and some things I wanted to compute. But the command to just create this table was getting rather large. So I decided to break this up a little bit, and to do that, I took all of this information in the select statement, coming up here to the beginning, and created a new table called combined database. And then, so I created it's a temporary table. So temporary just means that we're not going to save this table. It's not going to exist the next time we start up our program. Actually, the temporary table exists as long as I maintain this database connection. So if I discontinue this database connection, then the temporary table doesn't exist. But if I keep that database connection, I can actually close this script up and quit working with this particular database and come back, and that temporary table will still be there. Anyways, create a temporary table, so don't save it to the disk, and call it combined DB. And then what do I want to put in combined DB? Well, I want it to be all this stuff from the select statement. So now I have this new table with all this information in it, and it's called combined DB. So now I can do things with combined DB. So for example, down here, the actual creation of this table doesn't print anything out. So I printed out, here's the elements of the table. So this is actually the command right here that gives all this information. So select all the information from combined DB. Okay, fair enough. Now we're going to do some things with combined DB. So what I was interested in is if I look at a business, how many calories worth of cookies are they ordering? So I decided to separate this out by business and the cookie. Okay, so if I look at Joe's Eats, how many calories and sugar cookies did she purchase from me? I don't know why I want to know this, but I can figure it out using the database, so I'm going to. All right, well, we had looked at this idea of doing grouping using aggregates. So this is an example of doing grouping by aggregates. So I'm going to select the business name and the cookie name, and I'm going to sum the total calories. So remember, we made this total calories column. And then I'm going to do that from the combined database, and I'm going to group it by the business name and the cookie name and put it in ascending order. So if I do that, then this is the result I get. So we have the Elrod's Pizza has ordered 77,500 calories worth of chocolate chip cookies so far, and 77,000 calories in sugar cookies. And if you go over here and let's see, this is sorted by, yeah, this is still sorted by business name. So if you go over here and go down to Elrod's Pizza here, if we look at all the sugar cookies, let's see, we've got 10,000, 25,000, 35,000, 47,000, 59,000, 59,000, 77,000, I added something wrong. Oh, shoot. Nice job, math professor, with the arithmetic. Good job, buddy. Let's try this again. 12,000, 18,000 is 30,000, 42,000, 52,000, 67,000, and 77,000. Okay, I don't know what I added wrong. I must have added something in twice, but 77,000 in sugar cookies is what I get by adding all these up. I don't know why I'm double checking MySQL, I guess just to prove it works, whatever. Okay, so there we go. So this gives us then the total calories for the sugar cookies and the total calories for chocolate chips for Elrod's and for Joe's. Joe's ordering a lot of calories worth of chocolate chip cookies and sugar cookies and Scooby snacks. Now, it might be more interesting if we had some dollar amounts in here and asked what is the total dollar amount that Elrod's Pizza spent on sugar cookies or chocolate chip cookies. But yeah, this is the information I had, so this is what I used for my example. Okay, now I want to show you one last thing. So I ordered this in ascending order, and that's all nice and everything. But what if I wanted then, I've got, this total for the chocolate chip cookies and the sugar cookies in terms of how many calories. But what if I wanted the total calories that Elrod's Pizza has ordered, and then the total calories for Joe's, and the total well, for Scooby Snacks, there's only one order, but the total calories for Scooby Snacks. Could go through and compute that again from this table, right? I mean, we could do another grouping and put that all together. So we could just group by business name and figure out the total calories. But it turns out there's an extra command we can just add on to this grouping called a rollup. So a rollup does exactly this. So we get the 77,500 and 77,000 for Elrod. So this is the exact same set of commands here as the ones we just run up above, but I've added the with rollup. And the rollup just says, I'm going to add these two together for you. I'll add these two together for you. There's nothing to add together here, so I'm just going to report this again. And then, not only that, but I'm going to take these three results from the three different companies and put them all together. So the total calories that we have sold is 950,250 spread over Elrod's, Joe's, and Scooby Snacks. So the with rollup just summarizes your information from the aggregate function that you specify up here. Well, that's kind of neat. Okay, so just a hodgepodge of different commands here from SQL. We have the with rollup, and then we have the ability to create temporary tables and populate that with a join or some other select statement that you run that you think you might want to use. And again, we could have, if we wanted to, put all this stuff, the from, the group by, and the rollup. We could have put it on the end of this, but I just felt like, this is getting long enough and hard enough to read. And then again, a reminder that the other thing you can do is the left join, right join, and join. Now, honestly, I think for the most part we're doing joins, but trying to be thorough in our presentation of MySQL commands.